Swift is a type-safe language. Now, a type-safe language, it encourages you to be clear about the type of values your code can work with. If part of your code requires a string, you can't pass it an int by mistake. So this is one of the main things that makes Swift, in my opinion, such a great programming language. And the compiler is constantly helping you whilst writing the code to write clean and clear code. Now, the clear code is something that you get from experience, but writing clean code, the compiler helps you to avoid doing this. Okay, so it's very difficult to 100% give you understanding of how to write clean code. That comes with experience, but you want to try and remove code smells as much as possible. And if you can understand why you want to do this at a fundamental level, at this level, later on you'll start writing clean code without code smells automatically. And over experience, you'll learn how to not write code smells, and you'll see them instantly. Now, so we can see that our variable, this constant name, is equal to string, and it's David. And we can see through type inference that it says name is actually equal to string, and then age here is an integer equal to 45. And is living is a Boolean value is equal to true, and point at the moment is equal to an integer. So now what about if we want to change this point to be a points struct instead, and say 10 and then y, say 15, and now compile this? You see, this is where type safety kicks in, all right? Because cannot assign a value of point to type integer. Now, even though we've made it a variable, so it's mutable, we cannot change the type at so the type needs to be either inferred or annotated at declaration. So if we then said point 1 is equal to point, we are annotating here that this point 1 can accept a point type, all right? And so if we change this to now point 1 and now compile it, or now build it, you'll see that it builds perfectly fine, and we run it, it does basically nothing, but it still runs perfectly fine because during the declaration we annotated it with the type of point. And the compiler, and there are a few levels prior to it compiling, the intermediate levels, that checked this, all right, that said, hey, this cannot happen. You cannot have a point type being assigned to a integer variable, and this one here, an integer variable. So this is where type safety and type inference, they already stopped you from having a bug in the code, right, and a code smell. So because when you come to this later and you went, wait a minute, where's the x value of my point? It's not there. But now you can say, look, you can see the x value here. The code completion is telling you what properties this one struct has. So you could later date in the code said, well, wait a minute, point is equal to my point 1. And when we try and compile it, we don't have to compile it. It will just instantly tell us the problem anyway. Cannot assign a value of point to integer. So this is type safety. Now, other languages, they force you to have to annotate the type, but because we have type inference in Swift, we don't actually have to do it. However, once you have declared a variable a specific type, it stays that type and you cannot change it. Now, there are other ways and means of moving around this, all right, but we're not going to get into this. You should, in order to not write code smells or not clean code, right, then you should always, whenever you define a variable from the offset, is say, okay, this variable is going to be of type this, and it can only stay this type. So that's all I wanted to say, is that there is type, it is a type safe language, okay? But with type safety and type inference, you can really write clean code. And the clear code is when you start adding the likes of the naming conventions for the variables and the constants, making sure that if the code is not clear, and you can't make it clear without using comments, then use comments, and you make sure that you add white space when required, because it might all look like it's all nice here, and the compiler is going to be less code, less lines of code, but who cares? The computer is going to, the compiler is going to strip it all down and remove all of that white space and all of that irrelevant code, right, to compile it. So it's going to be gone anyway in the final code. So there's nothing wrong with having white space between it. You want someone to be able to look at the screen, and within the space of, say, 10, 15 seconds of quick scan, they should be able to understand what exactly that code is possibly going to do. And then, say, the next 1 minute or 2 minutes, when they really delve deep into the code, they should see exactly what that code is doing. And it shouldn't need anything more than that for someone to skip through your code all the time until they can start adding breakpoints and so on to be able to debug what's gone wrong with your code or where you need to change it. Okay, but there are other devices or servers that can scan for your code for code smells, etc., to force you to have to change these things as well. But with code review, the code review is the thing that helps you to learn how to write clean code and clear code as well. But the type safety and the type inference is the thing that is the tool that helps junior or beginner developers to learn, to force them to have to stay in that direction. Okay. So with that said, thank you very much for watching. I hope you got something out of this one video. Don't forget to like, subscribe, and if you do have any questions about the video or any feedback, then make sure you put them in the comment section down below. And that's it. Thanks very much, and ciao, ciao.